Where a for loop is used for side effects, a for expression is used to transform data, and it really is an expression that yields a result. So while the syntax is similar between a for loop and a for expression, the purpose is quite different. A basic for expression looks like this. So first I need a little bit of data to work with, so I'll create a list of 1, 2, 3. And with a for expression, it's going to return a result. So then we would say val, I'll just call it ys equals, and then I'll create a for expression. So for every x in x of s, yield, and I will just make this x times 2. And so you can see that the result of this expression is this new variable y of s here, and its contents are this list 246. And it ends up being that way because I doubled each element right here. And so again, the way you read this is you would say, for every x in x of s, yield, and then you put your custom algorithm here. So that algorithm can be anything you want. So you can multiply it by 10 if you want. You could turn it into doubles, which is kind of an interesting thing. So you don't have to just yield ints. You can yield whatever you need. So this returns a list of double, as you see right there. So going back to this example, one thing I want to show is that a for expression can also be multiple lines. So you could say val y of s equals, and this is a little awkward to show in the REPL, but I'll do this anyway. 1, 2, 3, 4. So let's say 4, and then I'll say x in x of s, yield x times 2. And so this is exactly, this multi-line solution here is exactly the same as this one. I just did it on multiple lines. And the reason I want to show that is because you can have multiple lines in this for block here. So I'll just put a comment here just to represent multiple lines. And this can be as many lines as you need as well. And I'll show more examples of this in just a few moments, but just for now, I just wanted to show that you could have multiple lines in both sections here in the for block and then here in the yield block as well. And before I get back to those multi-line solutions, I wanted to show this one more time. So this, when you have a basic for expression like this one, it's exactly equal to a map method call. So I could say val ys equals, and then I could say x of s map, and then just put that same algorithm in there. So I could say underbar times 2. And you can see the result is exactly the same. And actually, you can imagine the map method here being implemented as a for yield loop like that. And just to be clear, this is only the case for a simple for yield loop where you just have this generator right here and a simple expression in the yield block. And I'll explain that more in just a few moments as well. The next thing to show is that your algorithm can be anything you need it to be. So here, if I wanted to get the length of each string in this list, I could say names lengths equals, and I could say for name in names yield, I'll just do name.length this time. And so you can see that this list here contains the lengths of these strings up here. And so that shows that I started with this list of string up here, and then with this algorithm here, I could transform that into a list of int, which is saved in this variable here. And so what we have right now is a case where we have two different lists. We have this names list and then names lengths here, and this has the strings and this has the numbers. But one thing we can do, because we can yield anything you want, is we could yield both of those things inside of a tuple. So I could say I want to return the original name, and then I want to return the length of each name. And so this part here is a tuple right there. So I'm yielding a 2-element tuple. And this one is a string, and it's the name. And then this one is going to be an int, and it's the length of that name. And so you see the result here. So you have this list, and Bert is 4, Ernie is 5, and Grover is 6. And then you can see over here on this side, it shows the type. And so this is a list of a tuple. And again, the tuple is shown by the parentheses there. And it's a list of tuples where the first element in each tuple is a string, and the second element is an int. And the next thing I'd like to show is some more complicated for expressions. And to do that, I'm going to need a little bit different data. So we'll create a case class called person, and this will have a first name, make that a string, and then a last name, and that will be a string also. So we create that person. So I'm going to be a little lazy here. I'm just going to copy and paste this in so you don't have to watch me type. So what I've done here is I created a list of person, and you can see that type right there. And then these are from the Flintstones. So I have Betty Rubble, Barney Rubble, Wilma, and Fred Flintstone are 4 persons inside of my list right here. And this will allow me to start showing some more details. So I can say res equals, and I will do it this way. So we'll say so for every person in that list of people, I want to yield. And here I will do the, what do I want to do? I want to do person. So for each person, I want to do the first name, and I want to capitalize that first name. Okay, and so then you can see the result of that right there is this list of their first names, and they're all capitalized. And the key here that I wanted to show is that this thing here is called a generator. And the way this works is you can have as many generators as you want, but in this case, I'll just have one. And then the next thing I'd like to show is that you can have something that's called a definition. So I'm going to say first name, or f name here, equals p dot first name. And let me just go ahead and note here that this is called, technically this is called a definition. So I will scoot this guy over, and I'm just going to scoot some things over just to make the code a little simpler to read maybe. So that's called the definition, and now I don't have to have quite as much code here, and I can just say fname.capitalize, and that gives me the same result. And as things get more complicated, you can have as many generators in this block as you need to, and you can also have as many definitions in this block as you need to. And now the last thing I want to show is that in addition to generators and definitions, you can also have guards. So a guard is just a predicate or a Boolean expression. So you would say something like, what I want to do here, if fname starts with, fname starts with B, and then the rest of that is implied. So if fname starts with B is all you have to type, and then you'll get that result of Betty and Barney here. And that's a longer form, would be like saying if this is true, but the true portion of that is implied, so I don't add that there. And again, this is called a guard, an if condition, technically called a guard, and you can have as many guards as you need to. You can have as many generators in this area as you need to, as many definitions as you need to, and as many guards as you need to. And in fact, this one's a little bit easier to show, so I can just say, if the name starts with B, and if fname dot length, let's see, Betty is 5 and Barney is 6. So if name dot length less than 6, then that reduces the list down to Betty. So now you can see I have a guard here and a guard here. Next, I want to show 2 functions that are written with for expressions. So in this first example, what I have here is a function that I wrote. And a key here before I get into this is that because a for expression yields a result, you can use it as the body of a function. So here in this first line, I'm saying I want to define a function that has this type signature. So I'm creating a function. Its name is only Scala files. It has one input parameter, and that's a sequence of files right here, a sequence of file type. And then I'm going to return a sequence of file type here. And then I say this function is equal to this body here. So this portion here is the body, and it's a for expression. So I say for every file in files, if the current file name ends with Scala, then yield that file. And the way this works is when the sequence comes in up here, this sequence could contain 0 files, 1 file, or it could contain 1,000,000 files. And that for expression right here is going to iterate over this entire sequence one at a time, and it says, okay, if the current file ends with the name .scala, I'm going to go ahead and yield that file. And then when the entire loop has completed, it's going to yield all of these as another sequence of files. And if the expression doesn't find any Scala files, that's going to be an empty sequence of files. But if it does find files with the .scala extension, it will yield all of those again as another sequence. So there's probably two keys here. One thing I want to show is kind of a real-world example. Another one, which I think I've mentioned several times, is that because a for expression yields a result, you can use this as the entire body of a Scala function. Similarly, in the second example here, I'm using a library called Twitter for J. And what I've done here is I'm taking in a query as a string. So this function takes in a query as a string. It's going to return a sequence of a thing called mini tweet. So I created a class called mini tweet because I'm not interested in all the characteristics of a tweet. I was just interested in a couple of characteristics. So I believe I created this mini tweet class. And so then I say this function is equal to this body here. And you could easily argue that there's a couple too many things going on inside this function. So in this first one, I do the search here in this first line. That gives me some query results. Then I get a list of tweets from those query results in that second line. And then the for expression is the end of this function. So anything yielded here is going to be yielded or returned by my function as a sequence of mini tweets. And so here in the for expression, the only thing I was interested in those tweets is the status. So I say for tweets, for the status in the tweets, yield, and then I create a list tweet here. This is another type that I created. So all I'm interested in returning from this function are these three fields, which is the user, the text, and the time and date that it was created at. Honestly, I don't remember all the details in the difference between a list tweet and a mini tweet right at the moment. But what I can tell you is that the last part of this function is this for expression. And so it iterates over all these tweets and then yields the only results that I'm interested on. For each tweet, I'm just interested in the user, text, and the timestamp, because this is, again, the last portion of this function. That's the return value of the function, which results in being a sequence of what I was calling mini tweets.